This video will be on section 3.4, all about functions. And this section is really just putting together what we learned in the previous three sections. There might be a couple of questions that seem new, but it's just a different wording. So really we'll go over three questions here. We'll look at a function with a formula and talk about all the things we learned. Then we'll look at a graph and talk about a bunch of different things. And then the last thing is evaluating functions again, because what we do in next section is very relevant to what we're doing at the end of this section. All right, so we begin by looking at solving a question involving many of our new ideas from this section with a formula. What we're doing, we are given a function here, h of x equals negative 3x minus 9 over x squared minus x minus 2. We want to answer the following. The first one, it looks kind of like a weird question and asking, is the point 0, 0 on the graph of y equals h of x? Right, really what this is asking is h of 0, so if we plug in x equals 0, do we get out 0? So it's easy enough just to check this by plugging in 0 for x and check it. So h of 0, we plug in 0 everywhere we see x. We got negative 3 times 0 over or minus 9 over 0 squared minus 0. Guess you don't really need that parentheses, minus 2. And most everything here is 0 because when we multiply by 0 or do 0 to powers, it's all 0. So it'll all go away. And we are left with negative 9 on the top, negative 2 on the bottom. The negatives cancel and we get 9 over 2. And now we can answer the question, is h of 0 equal to 0? No. H of 0 equals 9 over 2. So this one's just a no. Or false, whatever it says. Right, the part B asks, what is the domain of h of x? Remember the domain, if the two things we are looking for is if there's an even root radical, which there is not, or if there's x in the denominator, which there is. So we've got to set the denominator equal to 0, solve for x, and then throw those numbers away. Right, so our denominator is x squared minus x minus 2 equals 0. We have different powers of x, so we want to factor it. It's already set equal to 0. Luckily, we have x squared here. And we want two numbers that multiply to negative 2 and add to negative 1. And that would be negative 2 and positive 1. And then we set each to 0. So we got x minus 2 equals 0, x plus 1 equals 0. And now solve each one. Add 2. For the one on the left, we get x equals 2. For the one on the right, we subtract 1 from each side. We get x equals negative 1. I accidentally wrote two negative signs. And remember, we are throwing these numbers away. So 2 and negative 1 are not in the domain. Now, if you practiced this enough before in the previous domain and range section, you might know how to write this in interval notation without drawing the number line, but it's always good to be certain. So we mark off our numbers negative 1 and 2. They are not included, so we get open circles. And we include everything else. We include to the left of negative 1 We include between -1 and 2, and we include 2 to infinity. And we write our interval notation now. So the 1 on the left goes all the way back to -infinity up to -1. Open circle means use up parentheses. We have more than one interval, so we have a union. Then the next interval is from -1 to 2, both with parentheses, because they're open circles. Then we have one more interval, so we got another union. And the last one is 2, going right forever to infinity. Right, and this is our answer in interval notation. -infinity to -1, union -1 to 2, union 2 to infinity. All right, part 3 asks for, well, that's not the third letter of the alphabet, but that's all right. What values of x does h of x equal 0? All right, so what we want to do is replace h of x with 0 and solve for x. All right, so our function 0 equals -3x minus 9 over x squared minus x minus 2. Right. So we've got this, and we want to solve for x. If we get rid of our denominator, which is always a good idea, it's actually even easier to think about 0 being 0 over 1, so you can cross multiply. Right, we can cross multiply when there's one fraction on each side. When we do that, the left side we have 0 times x squared minus x minus 2, and then the right side we have 1 times -3x minus 9. Now the left is great because 0 times anything is 0. And the right is also very easy because multiplying by 1 does nothing, so we got -3x minus 9. All right, so we want to solve 0 equals -3x minus 9. Now, something you can also remember when you want to figure out when a function equals 0, which we'll use going forward, and you have a fraction, all you have to do is set the numerator equal to 0. The denominator you can just not worry about. All right, so now we solve this. You add 3x to each side, and we get 3x equals -9. And then we divide each side by 3 to get x by itself. And we get x equals -3. So there's only one value when h of x equals 0, and that is -3. Right, so the last one is very similar, but instead of h of x equals 0, it's -9/2. So when it's not 0, it's going to take some more time. But let's go ahead and replace our h of x with -9/2. And so reminder, h of x is this. We're replacing the left side with -9/2. -9/2 equals, this is h of x right here, so I'll use this. -3x minus 9 over x squared minus x minus 2. This one's already a fraction on each side. We don't have to think about it differently, so cross multiply again. It's the best idea. On the left, we've got -9 times x squared minus x minus 2 equals, the right side we've got 2 times -3x minus 9. Right, now we need to distribute on both sides the -9 on the left and the 2 on the right. So that gives us negative 9x squared plus 9x plus 18 on the left. On the right, distribute the 2. We've got negative 6x minus 18. And now we want to get 0 on one side and factor because we have different powers of x. All right. Now, because I like having the biggest power of x being positive, I'm going to actually add everything to the right side. So I'm going to add 9x squared. I'm going to subtract 9x. And I'm going to subtract 18. So we've got 0 on the left, and on the right we got 9x squared minus 15x minus 36. Excuse me. Now we want to solve this. One thing I would do is there's a 3 in common, factor the common 3 out. And since it's just a number, you can divide it out too. So let's see that in action. Take the 3 out, so we get 3x squared. 3 out of 15 is 5. And 3 out of 36 is 12. Right. Normally, if we have an x here, we can't do anything about it. But since it's just a 3, it's just a number, we can divide each side by 3 and get rid of it. So we got 0 equals 3x squared minus 5x minus 12. And now, as far as solving this, we can't factor it anymore, so we have to use the AC method. We've done that a couple times in these videos. So I'm not going to do it all out written again, but I'll just explain it real quickly. 3 times, let me get a darker pen color. 3 times negative 12 is negative 36. And then we need to pick 2 numbers that multiply that and add to negative 5. And that would be negative 9 and 4. All right, so we got 3x and x as far as the front. And to get negative 9, if we multiply 3 by negative 3, that'll work. And then if we want the 4, if we multiply the x by the positive 4, we'll get exactly what we need. All right, we got it factored, set equal to 0. Now set each factor to 0. And just because I'm about out of room, I'm not going to do the 2 steps, but just write the answer here. If we subtract the 4, we get negative 4 equals 3x, and divide by the 3, we get x equals negative 4/3. That's one answer. The other answer, if we add 3 to each side to this one, we get x equals 3. And so we happen to have 2 answers for this part, and that's okay. All right, so really that's a rundown of a lot of what we did in the previous couple of sections. Now we'll have a similar type of question, but with a graph. It says let y equal p of x be the given graph below. We want to answer the following. We want to know what is the domain and the range, so we'll just start with that. Now, unlike the previous section, when we dealt with this, we saw all the graphs were kind of terminating. We saw 2 closed circles. This one doesn't have a stopping point, which means it's going to continue this pattern. All right, so since this one's going up and to the right, it's going to go up and right forever. All right, so as far as the domain goes, the farthest left we go, -7. We only want interval notation here. And it's going right forever, which means it's going to go to infinity. Right, so the farthest left we go is 7, -7. The farthest right we go, it's going to go right forever, so it's going to infinity. And now the range is the y value. So we want to look at the bottom of the graph, which is right here. Remember, it's a filled-in circle if it's not part of the end. So the bottom is -4. And then it goes up, and because of what's going on over here, it's going up forever. So it's going up to infinity as well. The y values of the graph are going up to infinity. Now the next two parts deal with the x-intercepts and the zeros, which are synonymous. The x-intercepts, these are the coordinate pairs where the graph hits the x-axis. And that happens at -6, it happens at -2, and it happens at 7. We got to make sure we write coordinate pairs. We got -6 for x, y is always 0 for the x-intercepts. We got -2, 0, and then we got 7, 0. And remember, zeros are pretty much the same thing. They're the x values of the x-intercept. So it's just -6, -2, and 7. But you got to make sure you don't get these backwards, otherwise they're both marked wrong. The next part here asks for p of 10. So it wants the y value when x equals 10. So let's scroll up to the graph real quick. Where x equals 10, it's right here. The y value is 3. Okay, so p of 10 equals 3. Part F asks for what values of x does p of x equal 2? Well, this is asking for when y equals 2, what is x? All right, so what I like to do is go to where y equals 2 is, move left and see if we hit anything. We hit 1 right here. And we move, there's nothing else to the left that hits it. If we move to the right, we hit it at 9. So we have two answers to this. We have -4 and we have 9. All right, so once again, -4 and 9. You can also draw like a dashed line or something to visualize it through y equals 2. But as far as this question goes, it's really a lot of what we need, really all that we need for the graphs. All right, so the last thing here is evaluating functions. And we know how to just plug in numbers now. We talked a little bit before about plugging in things with x. But here we're going to have a more complicated function just because this is what some things are going to look like next section. Good idea to see it now. It says for the function q of x equals x squared plus 3x plus 10, find each of the following. So the first one we have is q of -3x. And so remember what this means is we want to replace x with -3x everywhere we see x. So here we have x squared in the front. It's going to be -3x squared plus. We have 3 times x, but in place of x we got negative 3x. And then the 10 has no x on it, so nothing to do there. Now you want to simplify. But the first part here, negative 3x squared. If you do negative 3 squared, you get 9. And if you do x squared, that's just x squared. This one here, we can distribute the 3 through, and we get 3 times negative 3 is negative 9, so minus 9x, and then plus 10. There's no common terms here, so this is simplified. All right, so q of negative 3x is 9x squared minus 9x plus 10. All right, now this one, as soon as we bring in a plus, it's a little more complicated. But the idea remains the same. We want to plug in or replace x with 2x plus 6 for this one. So for x squared, we have 2x plus 6 squared plus 3 times 2x plus 6 plus 10. Now, what's important about this first one, when you square something like this with a plus or minus inside it, you don't square each part. Squaring means to multiply by itself. All right, so we're going to have 2x plus 6 times 2x plus 6. Now the second one is just fine. We can distribute the 3 through just fine here. So 3 times 2x is 6x, plus 3 times 6 is 18, and then the plus 10. Now this is the reason you don't want to square each part at the beginning, is when you have something like this, we need to FOIL it out. All right, so we do the first 2x times 2x is 4x squared. Then 2x times 6 is 12x. Plus 6 times 2x is also 12x. Plus 6 times 6 is 36. And then bring the rest down. If you want, you can simplify, because you can combine the 18 and 10 to 28. And now that we have all the parentheses and everything gone, the last thing to do is combine like terms, and then you're finished. And so the only squared term is 4x squared. There's nothing to combine there. For the x's, we have 12x plus 12x is 24x, plus 6x is 30x. And then the last part, the numbers, we have 36 plus 28, which is 64. So q of 2x plus 6 equals 4x squared plus 30x plus 64. Now if you square each part and you don't FOIL it out, you will miss this stuff right here, the 12x and the 12x, and you will get it wrong. So you have to make sure you do that part.